Welcome you all. I am Dr. Jagan, Associate Professor, Electronics and Communication Department from Rohini College of Engineering and Technology, Kanyakumari. So this video I have discussed about ADA wireless sensor networks.
Programming beyond individual nodes. Sensor actuated network systems offer some unique advantages. Dense networks of distributed sensor can improve perceived signal to noise ratio by reducing average distances from sensor to physical phenomena. In network processing and actuation shorten the feedback chain and improve the timelines of observation and response. And Unintegrated networks, the nodes, and infrastructures less network topologies reduce deployment costs. However, the greatest advantage of network systems are improved robustness and scalability. A decentralized system is inherently more robust against individual node or link failures because of network's redundancy. Decentralized algorithms are also far more scalable in practical deployment. They might be only way to achieve a large scale needed for some applications. Because of decentralized systems, spatial coverage and multiplicity in sensing aspect and modality, the detection, classification and tracking of moving non-local or local observable events require cross-node collaboration among sensors. Target tracking as a motivating example. Tracking is a canonical problem for sensor networks and essential for many commercial and military applications such as traffic monitoring, facility security and battlefield situation awareness. Given a moving point signal source or target in 2D sensor field, tracking system is goal is to estimate target state histories such as spatial trajectory on the basis of sensor measurements. From a tracking expert's point of view, each sensor node provides local measurements useful in estimating the target state. However, in most cases, only a relatively small subset of sensors contribute significantly to the estimation, owing a sensing range limitation. In this case, a good solution is a leader-based tracking scheme such as information-driven sensor querying IDSQ. So, fuse information from only the sensor that provide high-quality measurements. In below figure illustrate at any time instance, IDSQ designates a single node located close to the target as leader. The leader node fuses this high signal to noise ratio measurements and updates its current target location estimate referred to as the leaf. For most sensor types owning the physical properties of signal propagation, the sensor with high signal to noise ratio will be within a limited range of the leader node. So we can minimize the communication cost and latency for gathering sensor data. As the target traverses the sensor field and the belief evolves to follow its motion. The most informative sensors might no longer to be those closest to the current leader. A nearby sensor might then be selected to replace this leader on the basis of the updated belief and a criterion combining resource constraints with some measure of sensing utility such as mutual information. The current leader then hands off the belief to the sensor which becomes the next leader at the time t plus tau, where tau is the communication delay. The process of sensing estimation and leader selection repeat. As a vehicle moves through the sensor field, nearby sensor detected an elected leader node aggregates data from the active sensors and migrates the information from node to node as the vehicle moves. The sensor nodes collaborate primarily to improve sensing accuracy, and acceptable estimation quality might be achieved using only a subset of the sensor. One node, the leader, plays a key role in fusing other sensor measurement. If no leader is present, all sensors that form the contour are equally important. Each node might locally update and repair its observation of a contour section, but the global state can only be assembled from observation of many nodes along the entire contour. Hence, system designers must explicitly write code to maintain sensor connectivities in a neighborhood, discover the best node for handoff, invite neighbor nodes into the group, handle communication delays and failures.